Welcome to the eEVA Data Generation and User Results Analysis version 2.0 introductory video. The team members for this project include Andy Regietta and Emmanuel Henley. The product owner for this project is Dr. Christine Lassetti with mentor Stephanie Lund with eEVA and Mohsen Tahiri with Senior Design, under instruction of Dr. Masood Sajai. Alcohol abuse is a social epidemic where many people who suffer are unaware they even have a problem. According to research, short bursts of brief motivational interventions, or BMIs, have been proven to be effective, helping those that have these issues to realize the situation is out of control. Consider the original text-based Drinkers Checkup, or DCU for short, shown on the left of your screen, which is a web-based system that has been shown to reduce drinking by 50%. Although effective, the current text-based DCU is heavily dependent on text and therefore lacks engagement. To solve that problem, the Effective Social Computing Laboratory designed the Empathic Embodied Virtual Agent, eEVA. The eEVA system uses natural language processing, and it delivers a series of assessments on drinking motivation, dependence, consequences, patterns, and risk factors. Using established drinking measures for the DCU, eEVA goes through drinkers' inventory of consequences, severity of alcohol dependence questionnaire, alcohol use disorders identification test, Socrates, and brief drinker's profile. The new system offers a web-based modern approach to counseling alcoholism and seeks to help those in need with easy surveys and a fun and interactive experience just using your computer. The current system makes use of its complete intervention state machine, which controls the main flow of events of the application. Many of the states require access to MongoDB elements, which now are used for storage of survey information as well as state machine information. An administrator can edit the intervention content via user input and then add a state to the state machine by integrating this new state to the main flow of the application via the machine view. The state machine then acts upon the avatar, which is exported in WebGL format, and then the web page can be loaded to display the Unity scene as well as the newly added intervention content. Since version 1, the Effective Social Computing Lab have commissioned 4 additional avatars, making a total of 5 available to the user. These counselors have different ethnicities to appeal to different demographics. These avatars are used to interact with the users. All the content for the interventions have been obtained from the original DCU developed by Dr. Reed Hester and his research team, which can be accessed online. All the content is spoken by the counselors as well as displayed on the screen. Each person interacting with eEVA may have multiple choices or custom answers they can provide, some of these answers being temporarily saved to be used by other surveys. Despite the current system having most of the intended basic functionality, it still lacked content from the original DCU, which needed to be added. Overall, during this iteration, we were responsible for creating the initial as well as the in-session counselor selection menus. In addition, we were responsible for completing the sections of the intervention that were not implemented during the last iterations. The framework for the system was created using MeanStack by the Effective Social Computing Laboratory. The eEVA system uses a model view controller architecture, which utilizes a Mongo database for storing the data models. Express contains both routes and modules in the server tier. Then Node is used as the framework consisting of the server configuration and dependencies. The client-side tier contains the views that the user interacts with. The site can be launched via Chrome or Firefox, with the necessary JavaScript libraries rendering the WebGL avatar. Most items were implemented using the survey editor and state machine, which are rendered primarily in the survey view and editor view. These were controlled by the respective survey controller and editor controller, which updated the content into the repository. However, the other views like the counseling view are also necessary to display the modified content to the system's users as well. This concludes the introductory video to eEVA data generation and results analysis. We would like to thank you for watching.